you already did. Okay. And the order of presentation will follow the schedule that have already published in the conference website. If the presenter at the scheduled presentation is unavailable or absent, then we will move to the next presenter. Okay? Each presenter will have around 15 minutes for presentation and discussion. Okay, so we can split the time 30 minutes for presentation and 2 minutes for. Okay, there are around 4 to 5 presenters will present online, and the rest will present online. So I will invite the first presenter, Mr. Rudy Rahman. I think that Mr. Rudy Rahman already here in the Zoom, right? Hello, Mr. Rudy Rahman.
Hello.
Okay. So, Rudy, please deliver your presentation. You have 30 minutes for presentation and 2 minutes for discussion.
Okay. First of all, hello everyone. My name is Rudy Rachman. Today I will be presenting our paper, which title is Classification of Illustration Question for Indonesian National Assessment with Deep Learning. The author is this paper are me as the first author, Mr. Muhammad Alfian as the second author, and Mrs. Umi Laila Lali Yohana as the third author. In this presentation, it consists with 4 contents, and let's begin the first session, the introduction. Indonesian National Assessment is a new program that, hello? The presentation is not moving, I think.
Yeah, I can see your voice. I can hear your voice.
Please go to next slide, please.
Go to the next slide.
Yes. Okay. This presentation is consists with 4 contents. And next slide again, please. Again, next slide. Okay. Indonesian National Assessment is a new program that replacing the old standard Indonesian National Test or Ujian Nasional. It is begin in 2021 and it is divided into 2 types, numeracy and reading. Reading also divided into 2 types of this course, which is literature and information. Information is the focusing on the discourse that present an information for the reader. Literature is focusing on discourse that telling a story, and every discourse have image or figure to telling more information. Next slide, please. As you can see on the left side is the example for the literature discourse, and on the right side is the information discourse. Next slide, please. And then with the rapid development of information and communication technology or ICT and AI, Genpla and Manopiron developed an intelligent question banks. It is a framework to help teachers to choose question that is on question bank by student skill. Genpla and Manopiron is using machine learning to predict and classify question, but in this research, we are not focusing on intelligent question bank, but we only focusing how to classify question using deep learning method. Next. And then in this research, focusing on classifying Indonesian National Assessment reading discourse to information or literature by illustration on the discourse. And this is in this paper, we are using convolutional neural network or CNN, and the research data are collected from the website gurukemdikbud.go.id, and we only using figure or image that attach on the discourse as an input for the model. And this research is aimed to find the best result by using multiple convolutional architecture or backbone by performing transfer learning and fine-tuning, which means it is train all the convolutional layers. Next slide, please. And then next, we are going to material and method. Next slide, please. The first is data acquisition, which is the collected from gurukemdikbud.go.id website, and have to class information and literature. And different between the classes are information is contains some text and image contains some message to the reader, and literature is content illustration to help reader to imagine this situation. And information image in this dataset are 33, and for literature is only 26. And each image have different different size, so we are not resizing it, and we only take 26 images for each classes, and then we classify it by random pick for the information. And next slide, please. And all image resized into 224 pixels, and if image size is smaller than 224 pixel, the interpolation is bicubic interpolation, and if larger is using area interpolation. Data split for dataset is 80%, and for 10% is for validation and testing. Validation data is needed for detecting underfitting while training process. And here are the examples of image which using for trained dataset. Next slide, please. Next slide. And next, for increasing the variation of training model, because we encounter small dataset problem, we using data augmentation, which is the method are flip horizontal, save image to right or left by 20% of width size, and save image to top or bottom by 20% of height size, rotate the image by 15 degree to right and left, flip horizontal image are saved like before, flip horizontal image are so rotate like before, and we do 12 times random stretching and random distortion. And next slide, please. And the example of this image can be seen like this. A is the original image, and the other is augmentation result. B is the flip horizontal image, and so on. You can see, and for O and P is the random one of random distortion and random stretching method. Next, please. And next, the model configuration we use on this paper is using Python programming language and using TensorFlow class framework for deep learning configuration. And we are comparing with multiple backbone, which is VGG16, MobileNet version 2, Residual Network 50, Dense Network 121, and EfficientNet B4. We are using transfer learning from ImageNet and weight and fine-tuning the model. And there are two types of the output layer we are used for training. Softmax 2 units for categorical coarse entropy loss with categorical coarse entropy loss function, and when is with sigmoid is using binary cross entropy loss function. We can do this because we only classify to class, so that's why we can use sigmoid. Next slide, please. And this is the visualization of the model. We are using multiple backbone or convolutional architecture. The result will be flattened so the output of backbone can be used to train fully connected layer or dense network. The first fully connected layer or dense is 254 unit, and after that will be dropped out by 0.2 and so on. The output layer is based on what I said on the previous slide. Next, please. Metric evaluation that used on this paper is accuracy score and F1 score. And in the F1 score, there are micro, macro, and weighted for the evaluation. For the full research flow chart, we can see on this picture where first we resize image to 224. We do train validation task separation. We do data train, and then data train we use augmentation for random stretching and random crop by the Luo et al. At 2020 journal publication. And for data validation, it will be used for validating the model. And then we are test the model using data test. And then the output or accuracy information output is the class. And it will the evaluation metric using accuracy and F1 score. Next slide, please. And then we are using comparing with two different optimizer, which is ADAM and RMS prop. And the learning rate for the model is 1 micro. And if every 5 epoch, no changing on validation loss, learning rate will be decreased by 0.5 until it reach the lowest learning rate, or which is 1 nano at 10 nano. Maximum epoch for training is 200 epoch. We are also implementing early stop method to reduce overfitting chance. If validation is lower than 5%, then validation accuracy is 95%, then training will be stopped. And if validation loss not changing significantly after 10 epoch of training, the minimum L delta epoch is 0.01, then the training will be stopped too. We are also implementing model checkpoint to save the best validation loss while we train the model. Next slide, please. And the next session is result and discussion. Next slide, please. Like we said before, the comparison result are accuracy value and F1 score value, which is micro, macro, and weighted. And best epoch value to get lowest validation loss, and then total trend epoch and the validation loss at the last epoch, which is stopped by the early stop. Next slide, please. As you can see, there are two best. We can see the model, the comparison, the table of binary cross entropy result comparison. We can see here, VGG on RMS prop is the worst model, which is only accuracy-nya is only 50%. And if the total of epoch is 17, and the last validation loss is 138, which is it is really underfitting. And we can see the visualization. Please click the slide, please. We can see the visualization where we can see ResNet 50 with Adam Optimizer is the best and fastest result, followed by MobileNet V2 with RMS Prop Optimizer. Best and faster result is ResNet 50, and MobileNet is the second best with RMS Prop. Next slide, please. And then this is a table for category cross entropy result comparison. We can see still VGG 16 with RMS prop still has worse result, which is only 50%. And also the last full loss, validation loss, is also occur on overfitting. On VGG Adam is happening occur too. And and please click the slide, please, again. We can see the visualization. Hello, please click the slide. Okay. And we can see also the visualization of the category course entropy, which is best and faster result on category cross entropy loss function is ResNet 50 with Adam Optimizer, and followed by ResNet 50 with RMS Pro Optimizer. But it is longer than the ResNet 50 with Adam Optimizer. Next slide, please. And so overall, the visualization of the optimizer can be seen in this picture, where ResNet 50 with category cross entropy and adapt optimizer is the fastest with the best accuracy. And we can conclude that best model on every task is ResNet 50. Even in best validation loss is not lower than 5%. The accuracy and F1 score still achieve perfect. Binary cross entropy efficient net before is achieved the lowest validation loss, but the accuracy is only 75%, and F1 score is 73%, and best validation loss is not affecting accuracy score that much. Next slide, please. And then the last session is conclusion and for future work. Next slide, please. Conclusion that can be achieved from this paper, Indonesian National Assessment divided into two types, numeracy and literacy. In this research are focusing on classify literature into two class, which is information and literature, focusing to find best yet and model to classify the scores by the illustration. And the result is ResNet 50 is the best model, even with small data set to classify the images. And MobileNet V2 achieve score of yes.
I think your time is
Oh, okay. Okay. You can see all the conclusion and future work on the presentation. And that's all from me. Thank you for your attention and I apologize if there were any wrong words during my presentation. Thank you so much.
okay. Maybe is there any question?
I would like to ask questions about the data that is taken. Any specific reasons that you only take 26 images from the materials, like if I'm not mistaken?
I'm sorry, but the voice from the mic is not quite good, so I can hear the question. Can
My
you?
voice cool now?
Can you hear my voice?
Yes, I can.
Okay, so in your slides, in the material slide, you say that you only take 26 images. Any specific reasons that you only take 26 images?
Can you go to the slide presentation slide? Mana kan? Acquisition. We only can capture 33 images and literature for 26 because on Guru Kemdikbud, it's only have that image. I already so that's why I using many augmentation method so to increase the variation of the data. What is the question again? If you can say it again.
You say that the data set is 33 images and the literature is only 26 images. It is from the data collected from the website.
Yes, it's only collected on
It is,
Guru Kemdikbud.
it is sufficient to do your research, or do you think you need to add more data sets?
Because the Indonesian in this paper we only classify Indonesian National Assessment and Indonesian National Assessment questions and the figure can only achieve from that website basis. That's why we only use from Guru Kemdikbud website because it is official website to get the result for Indonesian National Assessment.
I think that is all for my question. Thank you very much for your answer.
Thank you.
Okay, now we can move. Thank you, Lily.
Yes.
So, share. Move to the second presenter. Miss Mr. Hinakani from Guru Gobind Singh Indraprastha University, India.
Hello everyone.
Hello. Okay. Mr. Sina, please.
Yes.
Please,
Hello. Yes.
presentation. Yeah.
I'm sorry, ma'am. Hello.
Hello.
Hello everyone. Hello everyone. I am Hina Kalim from Guru Gobind Singh Indraprasth University, New Delhi, India. Today I am here to present my paper titled "The Effect of Activation Function and the Number of Layer on the Identification of Citrus Leaf Disease using CNN." Next slide, please. The outline of my presentation is abstract, introduction, literature review, methodology, result analysis, conclusion, and references. Next slide, please. Abstract. Why citrus leaf is important? The identification of citrus leaf disease is essential for crop health, economic stability, food security, and sustainable agriculture. The aim of this paper is to examine the effect of various activation function as well as the number of convolution layer in the neural network. In this paper, I am using citrus leaf disease data which is publicly available that contain four different type of disease. Next slide please. Introduction. Identification of citrus leaf disease using CNN is important for early detection, precision in disease identification, reduce crop loss, and ultimately it is benefited for agriculture industry. In this paper I am using three different type of activation function: sigmoid, tanh, rectified relu rectified linear unit. In this paper I am using four different type of architecture: three convolution layer, four convolution layer, six convolution layer, and VGG16 model. Next slide please. Literature review. In the first paper, author suggested support vector machine for the classification of citrus canker, or that is a different type of mm, disease, and obtain 97.8% accuracy. In the second paper, author suggested random forest for the detections of disease in grape slips and obtain 86% accuracy. In the third paper, author suggested K-meal clustering algorithm to identify diseased area in the grape leaves image, and for the classification they use support vector machine and obtain 90% accuracy. In the fourth paper, author suggested bi-label thresholding uh, to segment the disease citrus leaves image, and for the classification they use hidden markup model for the classification. Next slide please. Next slide please. In the fifth paper, author suggested a transfer learning approach for the detection of disease in the grape slips and obtain 99.23% accuracy. In the sixth paper, author suggested LXNet and RASNet pre-trained model for citrus leaf disease detection and obtain uh, 97.92% accuracy and 95.83% accuracy respectively. In the seventh paper, author suggested hybrid model of CNN and random forest for the detection of disease in citrus leaves and obtain 87% accuracy. Next slide, please. Methodology. In this paper I am using citrus leaf disease data that is publicly available, that contain four different type of disease, that is black spot, melanose, cancan, greening, and uh, there are 58 images of healthy and 551 images of unhealthy images. Convolution neural network. Convolution neural network is the subset of machine learning. It is one of the various type of artificial neural network which are used for different application and different type of data. Sorry. Convolution neural network consists of three layer: convolution layer, pooling layer, and fully connected layer. Convolution layer. In convolution layer, we apply convolution operation. Convolution operation is the heart of CNN model. It is responsible for detecting age and features from the images. Convolution operation is nothing but the element wise multiply some operation between image and filter. uh, Pooling layer is it is used to reduce the dimension of the images and enhance the feature of images. Reducing the dimension of image reduce the computational cost and the number of operation required to process the images. The fully connected layer, the purpose of fully connected layer is to classify the detected feature into category. Fully collected layer is just like a CNN, just like artificial neural network, where every neurons is connected to every other neurons in the next layer or the previous layer. Next slide please. Activation function decide whether a neuron should be activated or not by the calculating of weighted sum and further added bytes to it. In this paper I am using three different type of activation function. First one is sigmoid. It is the characteristics of sigmoid is it is continuous and differentiable. The range of sigmoid is my 0 to 1, and and it is a smooth and also bounded function. In the next slide please. Hyperbolic tangent activation function, uh, it uh, it is similar to sigmoid activation function. The range of this activation function is -1 to 1, and it is also a smooth and differentiable within the range. Next slide please. ReLU activation function, uh, it is just look like linear activation function. It is uh, also differentiable and continuous within the range. The range vary from 0 to infinity. Next slide please. The characteristics of activation function and the advantage or disadvantage of activation function. Sigmoid is diminishing gradient vanishing problem is applicable, where in sigmoid and tanh relu will reduce the vanishing problem. Optimality sorry limited optimization is difficult in sigmoid and partial in tanh and relu. Next slide please. The result in second convolution layer, the best accuracy is obtained by relu activation function. In fourth convolution layer, the best accuracy is determined by tanh activation function. In the sixth convolution layer neural network, the best accuracy is given by tanh activation function. Uh, and from the VGG16, ReLU will give the best accuracy. Next slide, please. These are graphical, sorry, chart representation of my experiment. Next slide, please. Conclusion. uh, uh, in this paper the aim is to examine the effect of various activation function as well as the number of convolution layer. After comparing different type of activation function, we found that the neural network with 4 convolution layer and tanh activation function will give the highest accuracy, which is 71.35 35%. So we can conclude that the farmer and researcher can use the activation function is deeper network for the reliable disease detection system. Next slide please. Next slide please. These are my the references. Next. Thank you.
Is there any question from the audience? Okay, I have one question, Mr. Lima. So in your research, you get
Sorry, ma'am, your sound was not
okay,
clear for me.
yeah. From your research, you get that for convolutional layers and Tanha activation function is get the best result.
Yes,
Do
ma'am.
you think it will be same if we apply to other classification problems?
Uh, it's depend on the different type of data set. It is not compulsory that the activation function tanh will give the best result. For my data set, the activation function tanh will give the best result.
Or maybe you can get analysis already analyzed that what kind of the type of the data set will get the result with best accuracy using Tanha activation function.
I am taking the citrus sleep disease detection, citrus sleep data that is which is publicly available in TensorFlow library itself, that contain 551 disease data and 58 images of healthy, which will give the highest accuracy of with the help of tanh and 4 convolution neural network.
Okay, thank you, Mr. Gina.
Okay.
Uh, is there any question? No question? Okay, so we can move to the next question. Thank you again, Mr. Gina. Okay, let's see how the third presenter is Muhammad Sadewa, Wijaksana.
Okay, thank you. Can you hear my voice clearly?
Okay. Oh, you listen online?
Yes. Can you
Okay.
hear my voice clearly?
Okay.
Okay. I will put my everything.
Okay, yes,
Okay, good afternoon, everyone. My name is Emsadewa Wicaksana Wibowo from ITF, and this is my research with my lecturer, Iketut Edi Purnama and Reza Fuad Rahmadi. Our research is modified 3D unit for brain tumor segmentation. Okay, next. Yeah, this is the my content of my slide. You can see that there is a problem, the previous research, my purpose, and the result of our research. Okay. Okay. Before we go to specific problem, we have to see the general problem of my research. The general problem is based on cancer.net, brain tumors account for 85% to 90% of all primary central nervous system tumors. Worldwide, it estimated that there is 308 and 102 people were diagnosed with a primary brain or spinal cord tumor in 20 and 20. And estimate that 18 1,990 deaths from primary cancerous brain and CNS tumor. Well, this is occurred in the United States in 20 and 23. In the meantime, manual segmentation by professional is a time-consuming and subjective procedure that results in inter-observer variability. That is why based on different professional have the different results. So that is why we have to standardize that with CNN or UNET. Okay, next. Okay. The specific problem based on the previous research that Wong et al. extract extract the multi-scale visual feature using dilated convolutional feature pyramid and added a residual module to deepen the network structure. But it has limitation in terms of gathering multi-scale information and delineating complicated tumor model precisely. That is why we propose the best method to solve that previous research. Okay, next. Yeah, this is my proposed method that we have to collect the data training, we are do pre-processing, including the data augmentation, and we train with our architecture that is modified UNet, and we validate our data with specificity, their score, and sensitivity to make sure that our result with the ground truth is same or not. Okay, next. Okay, the data set from our research is using breadth 20 and 20, which is from which is our get the data from University of Pennsylvania School of Medicine, or you can get it in Kaggle too. The total subject is 369 subject or patient, you can call it, which is there is divided to two parts. The first is 76 LGG or low grade glioma, or you can say that benign tumor. And the second one is 293 AGG or high grade glioma, or you can call that malignant tumor. So, and actually, in each subject, there is a different modality, you can call that. Modality is T1, T1CE, flare, T2, and ground truth. Ground truth is the master of the result we have to achieve. And T1, T1CE player, and T2 is the modality of the subject to analyze from radiology. And this data set is get from the MRI. And the data set is 3D. Okay, next. Okay, each image you can see the size is 240, 240 and 155. And you can see that there is a different sequence between player T1, T1CE, and T2. And there is a different size or image between these modalities. Okay, next. So the proper processing, we are using a center crop, which is there is a huge data in 3D, and we have to cropping the data, which we can crop that in 128, 128, 128, and when we are using data augmentation like horizontal and vertical flip and random gamma to make sure that our data can more various and our model can more robust to analyze the another data. Okay, next. Okay, this is the our modified unit or our process method. There is a two pathway. The first is the context way pathway, and the second is the localization pathway. The context pathway is the capture of the contextual information from the input 3D image, and the localization pathways is the combine the contextual information with high resolution features to produce more accurate segmentation result. And maybe you have a question, what is the different modified unit and and the basic unit? The difference is we are adding more improvement to increase our performance model. The improvement is we are added 4-layer context pathways as encoder, and we are also added 4-layer localization as decoder to make our architecture more deepen to analyze. And in addition, we added element-wise summation to incorporate in information from multiple sources. So the general data is we can get information. Next. Okay, this is our result. In our research, we are compare with different model like ResNet, UNet, and our method modified unit. We can see that the performance comparison without augmentation, our proposed method is less than the unit. We can see that unit is more higher than modified unit. But when we are using data augmentation in our model, we can see that our method can have the highest value than the unit with the more deepened accuracy or architecture. We are compare the ResNet, UNet, and modified UNet, which is the where is the best result from the model. Okay, next. Okay, you can see that this is the sample of our model, the 3D ground truth, which is the which is the segmentation, the localization of the tumor, which is where is the location. Thank you for the presentation. Maybe there is another question.
Okay, Mr. Sadewa, uh,
Okay.
I have two questions for you. Please slide about type and no. Yes. Can you explain about one subject? What is the relationship with the type of tumor? And the second question, please into slide modify unit. Okay, I want to know about where is the modified unit you in the sentence mean. Maybe you can show in the architecture of unit in the left side. Thank you.
Okay, thank you for the question. Okay, the first one is breadth. Okay, the question is there is a data set breadth 20 and 20, which is the subject is 369 subject and divided into two parts, LGG and HGG. The LGG is local glioma, or you can call it benign tumor, which is had the total number is 76, and the HGG is high-grade glioma or malignant tumor, and the total is 293 number. Okay, so and each subject there is a different modality. If you see in the radiology, maybe radiology when we are analyze the where the location of MRI, there is another modality like T1, TICE, FLAIR, T2, and grounded. And grounded is have a different within and which is in each modality had the different. Like T1 had the contrast in A, TICE in another, and the second one is in the modified unit. there is a we are using our second more deepen, and you can see that we are using 4 layer. We are added more layer, which is you can see in the instance norm ID, instance norm 3D. We are added instance norm ID, and we are using Likirelu to optimize our architecture, which is when you using another method like UNet basic, maybe you only use the ReLU and only had the simple pathway, not the divide into context and localization pathway. Maybe like this. That is the answer to your question.
Show the differences about original unit and modified unit, maybe with the image or something else.
Okay, actually, there is a good question. The this unit we are using only using the Core 3D, and we are using ReLU to maximize our unit. And in the modified unit, we are using the ReLU, and we add more layer, more deepen. We add 4 layer context pathway as encoder, and we are added 4 layer localization pathway as decoder to make our model more deepen. Like you can see, we are using upsample, ReLU, and instance norm 3D to make our model more deepen. And the unit basic, we are have a simple, what we call it. We are not using element summation to not make our model more deepen. Like this.
Okay, thank you, Mr. Sandewa. Okay, this is the end of your presentation time. Let's give applause to Mr. Sandewa. Okay, thank you. We move to the fourth presenter. Benny.
I'm here.
Okay, Mr. Benny. Okay, we have 15 minutes for presentation.
Okay, good afternoon, everyone. My name is Benny Hansen Levindra. In this moment, I will present the paper Batik Style Transfer into Fractal Shape. Next slide. Okay, the first section is about style transfer. Here, I will explain what is style transfer and what this study aims to do. Next slide, please. Okay, in this context, style transfer refers to the process of generating a new image from 2 given images. The new image has the content and shape of one image, but with the style, the coloring of the other image. So for example, I have an image of a dog and an abstract art. I put the dog as the content image and the art as the style image. The result is a picture of the dog, but colored abstractly. Next slide, please. The application of the style transfer itself also extends to batik. Previous studies investigate neural style transfer application with batik motif. Neural style transfer being style transfer using the neural network architectures. These studies try to produce new batik motifs using neural style transfer. Next slide, please. So the focus of the study is to perform style transfer between fractal images and batik images. The reason being, both fractal and batik share identical trait, in which both have intricate details, and there is a form of cell similarity. If you see on the table to the right, they quite share identical trait. Not only that, the focus of this study also aims to evaluate whether the transfer style can be regarded as batik motif. This is because there is no objective evaluator for style transfer image, and the previous studies did not perform any quantitative evaluation. Next slide, please. So the next section will be about the implementation. Next slide. In this study, we used a pre-trained VGG19 architecture as the model. The architecture itself, the application of it, is similar with previous studies. They were also using a pre-trained VG19 as their model. This is because training it will require some extra time, so might as well use a pre-trained one to save the time needed. I will explain how it works. So neural style transfer works by extracting features from the input images using the convolutional neural network layers present in the architecture. The features are then computed into the loss function, which is then optimized. And when it happens, the model will start update the pixel values of the new image. This process is done repeatedly until certain quality from the image itself is achieved. However, a previous study found that the best convolutional layer to be used to transfer batik style is the block tree conv1 layer from the VG19 architecture. This is because batik generally have intricate details. As such, it is hard to be captured by deeper layers in the architecture. So the wheel weights used in the layers, this weights adjust the contribution of each layer into the final image. So in the study specifically, the weight factor is set to only permit this block tree conv1 layer for style contribution. Unlike previous studies, this model also took into account the total variation. The total variation loss can help denoise the image. Later slide will show the effect of this loss value. Next. So style, as I explained before, style transfer use a content image and a style image. For this study, the content images will be the fractal images, while the style transfer are batik images. The fractal use will where the Julia sets developed with an iterative function system, and the batik use where the batik Liong, batik Nitik, batik Parangkusumo, and batik Megamendung. Next slide. There were some pre-processing and post-processing done in the study. So from the content image, the fractal, a grayscale image and a blackened image will be produced. The grayscale image serves as the content image used in the style transfer, so that it will be the base of the generated image. This is done to save time in transferring the batik style. The blackened image, on the other hand, is used to filter the fractal shape away. The area outside the shape is then colored with a chosen color commonly found in the image. This study used a key nearest network classifier to help find these common colors, which is then manually picked to recolor the outer area. Next slide. And the last section is the result and analysis. Here are the results. This is the first image. So on the left, we have the image after it is transferred, after the batik is transferred, while on the right, we have the filtered image. Next. So the first and the second image use the batik liong. Next. And this is the third image. So for this one image, the weight for the total variation loss was made higher, the previous one being 30, but this one is multiplied by 10, so it's 300. So you can see the areas around the fractal shape look crudely painted. This is what I said about being the noise. So the result of the style transfer can be somewhat of a there are some static parts in the image. So using the total variation was hoped to lessen the appearance of the static. But as it turns out, for this one image, it rather paint it worse. Next image. Next image. Next slide. So this is another one. This is with batik Parangkusumo, of course, not with the high total variation weight. Next. And this is the batik Megamendung one. It used the same weight with the batik Nitik. However, this one has a rather slightly better than the batik Nitik one. Next. So there is no objective evaluator for the images. So a survey was conducted to evaluate the quality of the generated image. We used the public opinion. There were 38 participants, most of which are of the computer science background. Next slide. Generally, they have positive opinions on the synthesized image. Next slide. And when compared with the filtered ones, they are not so different at all. Next slide. However, majority of them firmly believe that the image were made by computer. Next slide. So I did a hypothesis test, a chi-square test, and I only found a significant difference for only the first image, while the rest are not so different. So it can be said that a simple style transfer is enough to be received as batik by the public. So the unfiltered one is already enough to be considered batik by them. Next slide. There were some errors from the resulting image I present, that there are colors and features that should not be present in the style image. However, they appear in the final synthesized image. Next slide. I don't know what caused this, but I hypothesized that this error could have been caused by the style weights set in its layer. However, I did not have enough time to further explore it, so it can only be left as assumption. Next slide. So the conclusion that I can give from this study is that images generated from batik style transfer can be considered as batik in the eyes of public opinion, though most of them can identify that some of them were made by computer. And this is just my assumption, but I believe that the style weight factors for each layer can majorly influence the result of the synthesized image. Thank you. Any question?
I think maybe they should be. Is it okay? Is it fine if I have two questions? I want only one. One question. Have time then the second. I would like to ask about your complex number. Is my voice audible? Do you hear my voice?
Yes, I hear your voice.
So you mentioned something about your complex number in pre-processing your image, if I'm not mistaken. How do you
Yes.
determine your complex number?
In what way?
How do you have that number?
Oh,
I recall
I
you
did
have
not.
specific numbers in your slide presentation about the complex.
It's the next slide. So from this one, this table was from the previous study, the one made by Isan from the 2021 paper. He presented, he made a comparison between Julia Set's fractal and batik motifs. And along with it, he present the complex number used as the constant to help form the Julia Set fractal. So the how do I get those numbers from the previous study? Is that adequate to answer that? I'm sorry, I can't hear.
Sorry. So, can you hear my voice now?
Yes, I can hear.
So the complex number you mentioned is from the previous literature. Do you think, in your opinion, do you think the complex numbers still relate to your research?
I did not study it further, but maybe they have some influence on the final image. So I only pair the one complex number with the corresponding batik motif, but I did not try to make it so that each complex number is paired with another batik that is not correspond to it. The result might have been different too.
Thank you for your answer. Any question? So in your research, you generate modified by the images having fractal shape, right?
Yes.
Uh, what do you think if I have a different method, such as I just combine two image, one are the images and the other is the fractal images combined with a certain way. Then I do the post processing like filtering, like you do in your research. You think it's going to get the same result like yours?
Can you repeat that? I'm sorry, can you repeat that?
Okay. If maybe I use the simple method like combine two images, just combine one by the image and one fractal image, just combine with certain weight. Then after that, I do the post processing like filtering, etc., like you have done in your research. Can I get the same result as yours?
Genuinely, I think it might, but as I seen it, the model mostly transfer the coloring, the motif too. But if I look at it closely, it's not so similar with the batik motif presented as the style image. So it might, but I genuinely don't know because that needs to be further testing. But this method I use is mostly automatically transferred from one image to another. However, even then, the shape is not the shape itself is not so similar with the original batik motif. So if I just combine both image, I doubt that it can resulting in the same image, in the same generated image, unless the style image, the batik itself, is further modified. So there's that.
Sir, Benny. And also, thank you for the nice presentation. Let's give applause to. Thank you. And we move to the fifth presenter. Manika.
Okay, good afternoon all. So, my name is Muhammad Iqbal. I come from Department of Mathematics, ITS. Basically, I just help my colleague from National Taiwan University of Science and Technology. So we brings research about with entitled mobile vision transformer for surface defect classification from a tiny data set. So basically, it's just like a case study, or you can say just preliminary research. So we want to focus on the surface defect classification because most of the time they try to recognize it or recognitions. We try to research on different viewpoints by classifying them, and also we are a little bit make a case study. What if we only classify from a small set data? Because if you think about in a large factory, maybe they need a huge data set. But what if we only make it simple by using like mobile phones so that we can classify whether the surface is defect or not? So, thanks, maybe. So this is the outlines for my presentation today. So I just briefly give the introduction of this research, and then glad it works, and of course the method, and I try to discuss the result, and of course last but not least I will conclude the presentations. Next. Next. So this is why is hot roll street, because basically we can see in many real application, like in a car or maybe like in the trains and etc. Nice. So as I mentioned in the beginning, hot roll street lights are usually equipped with surface detection system that can detect defect on the street surface. However, the system is less accurate in classifying defect. Consequently, this case prevents the system from completely replacing manual work and only serve as an aid. Okay. So the challenge here is that how do we play with a tiny and imbalanced data set, because of course we cannot see like a balanced data set for each defect types. And then, as I mentioned, we just like doing a case study here. Basically, the public data set is huge, but we just want to play on the tiny one. And then, how do we construct a robust lightweight model? Because as I mentioned, maybe we can classify the surface defect on a mobile phone. So we try to use a lightweight model instead of the deep learning models, the heavy one. So the goal here is that we want to classify the surface defect from a tiny data set efficiently. Next. So here, what we try to review some studies on surface defect classification. If we talk about like traditional machine learning, it requires feature extraction. I mean, you guys already know if we play on traditional machine learning, we need to do like feature extraction, right? It differs when we talk about like deep learning model, because deep learning model, that's the job for deep learning model to extract the feature automatically, right? So sometimes if you try to extract your feature on the deep learning, I think it's a wrong way. Of course, it will be very overfitting for your model. And then the classification accuracy of often not particularly high, because like let's say back then we have like supervector machine as the robust model back then, but yeah, they already have like the upper bound. So let's say you can only up to get the accuracy 80%. Compared to deep learning, we can like moving up to 90% by adding more and more data. And yeah, for recent deep learning, we just see or review on the recent study from Fang et al. In 2021. They applying REC-VGG algorithm to classify the defect and obtain reasonably good result compared to the existing model. However, of course, REC-VGG considered to be a heavy model, and it has long inference time to classify the defect. So this case initiate a negative impact on the industrial process. As I mentioned, we just were trying to play on tiny data set and also in a lightweight model. So this is our proposed method. Basically, we just adopting a model from fission transformer, the lightweight ones. And because of we trying to play with the binding data set, of course, we just need augmentation data, right? So here we play on two augmentation methods. First, the offline, and second, the online versions. So this is for just the VIT lightweight model architecture. Next. So here are the outline data augmentation. We apply geometric transform, scale motif, and apply transformations. So by doing that, we will got some. We get the balanced data here. Next. And this is just the online data augmentation that we use, color jitter and the flip horizontal. Next. Yeah. We move to the result. This is the data that we use, as I mentioned to you. Basically, there are huge data in there, but we just take like 1,360 different image. You can just download it from this link. And next. And this is our setup, the environment in the GPU GPX 1080, and then deep learning framework will be PyTorch. And we set epoch and date size on 132. Optimizer, of course, I done optimizer. And for the train validation and test data set, we use like 60, 20, and 20% settings in this case. Yeah, next. So here is the learning curves. As you can see, they are converged for all models, but what we try to add in our model, basically, previously I didn't mention it, but we also try to use fine-tune on mobile, because nowadays, even like computer vision always trying to get fine-tuned, right? Even like if you play on large language model, they try to fine-tune so that they get more lightweight model instead of the heavy one. So as you can see here, the fine-tune model, they provide us the best one. Even like in the red one, the strongest line, offline augmentation, they still like oscillate, so I think it's not good one, the red line here. But once we doing offline with the augmentation and the fine-tune, we got the best one. Next. And this is our result. Ours is something like here. Can be seen. So I think we got like here 98.93, and the balance accuracy we got 97 and 78. Next. And for, as I mentioned, because we try to like efficiently, we also show you the number of the parameters and also the inference speed. As you can see here, the original one like 80,000 parameters, right? We only use like only 4,000 here. It's very small, but yet we get a good accuracy. And as you can see, the inference speed, even it's a millisecond, we still believe compared to like 100 millisecond compared to 33 is efficient, more efficient. Next. Yep. So here are our conclusions. We present a model with a new parameters and robust performance for surface effect classification on road steel strip. Basically or specifically, we integrate mobile VIT, efficiently classify the surface defect image classifications by also adding fine-tune, and then with a tiny number and imbalanced data set, we add augmentation data, within our 17 concept, and we test the proposed model on a benchmark image dataset for specific. And as are already discussed, the evaluation result, the proposed model outperformed than the state-of-the-art models. So for next, we believe that the final inspection can be done on mobile device with fast procedure in this case. So thank you very much. Miss Nung would like to.
Thank you for the nice presentation.
Okay. Good afternoon. I want to ask a question. It is a remarkable presentation on the research. And there's something that I need to clarify. We once know that we need a solution and large data to perform a good analysis. Now, after your research, do you think we are able to perform a great or even better analysis even though we have tiny and imbalanced data set?
It's a good question. That's all? Okay. So I will try to answer. Basically, yes. Even like previously, I also play with brain tumor simulations. The doctor, how to say, challenge us. They want to know the volume of the tumor, but they only give us only 2D, like 8 slides. So how can we play with those few slices images to construct the 3D tumor? So we just play with augmentations back then. And also, of course, we need to add like the fine tune or the pre-grade so that we can get optimal parameter. So let's say in text, in natural language processing, we also know like LoRa, if you know. LoRa is trying to get small parameters, but they can produce high performance. So now it's how to say, if you play with small data, now it's impossible to get high performance because of the difference.
Thank you so much.
Thank you. Any questions again?
In the slide of the experiment design, I think there is the slide that
Next.
there's a mention about the
Next.
online applications.
Next. Yeah.
Slide.
After this.
Next.
Was,
This one.
oh,
This one. There is no online application.
Yeah. This is a little bit we forgot to add it. But basically, we do we also still how to say it's too long, right? If we add like online.
So
Basically, we do the online.
you mean that if you write offline without indicator, it is offline plus online.
Online. We do put it down. Sorry.
Practically, what did you do in the final tuning?
Practically.
How do you do the final?
Oh, yeah. So it seems like pre-training. So we try to pre-train our model until get the optimized one. Then we fit to our next model. Let's say something.
Not just the transfer.
Yes. Not transfer learning because transfer learning is something like still on the model, on the learning, but it's kind of like different ways. Yeah.
Okay. Testing. Okay.
Thank you very much.
Okay, thank you very much. Let's get Ralph.
Hello everyone. Afternoon. My name is Muhammad Rahmi, and today I will present you all about my research as convolutional neural network or CNN, excellent Bayes-Zero model resulting for 5D basis classification. The author for this research is Barry Spike, including me, Rahmi, and there is Mr. Harid, Mr. Aman, Mr. Bayu, and Mr. Yusuf. We are from Faculty of Science and Technology, Surabaya State University, Surabaya. Next. Okay, the outlines of this research is there is introduction, problem, contribution, network, and then methodology, research association, and then conclusion. Okay, let's move on. The introduction section. The rice is a crucial agricultural commodity Indonesia playing a vital role in maintaining national food security. But this triggered by the disease of the bad disease that can cause crop failure, that risk to food security, and the one effective method for attacking this in this rice plan is by examining the characteristic of the disease through the link of the rice plan. The human eye can do this, but the human eye is low accuracy. So the right option is use the system to do this task. And then the most promising approach to develop such a system is through the use of deep learning methods. And the one of the class of deep learning method is there is CNN that can that can be discussed. And one common challenge encountered when applying this method is access runtime and memory usage. As you know, the deep learning is for our laptop is or device is very hard to do. It's very hard to process it. And one common challenge is this: the models complex numbers number of parameters next. And the problem is that the farmer productivity are influenced by both the weather and various diseases. Numerous instances of profiler can affect to national food security, as I said before. Precisely, disease is one of the contributing factor because this is the disease that can very easy to see in the receipt. Identification by human is with a lot of accuracy, and a system is needed that can identify the disease with the greater accuracy as well. Next. In contribution section, there is 3 contributions in this research. The first contribution is scientific contribution. This study contribute to the field by innovatively classifying classic disease through the utilization of deep learning method. And the reference contributing is this research provides essential reference for understanding the level of accuracy and treatment associated with the classification of classic disease through the deep learning method. And the future impact the anticipation is that this contribution will include and improve medical farmers in innovation. Next. This is 3 main reference that I use for this research. The first reference is from Angrini and France. This research is tell me that CNN is outperformed both LCN and LSTM in multi-level classification with average accuracy in 88.54%. And the second reference is from Priyanka and Kumara. This research is telling me that CNN method with the architectural model is achieve more accuracy than normal CNN. And the last is reference from Julianto and Sunyoto that tell me accuracy architectural model with few layer and parameter perform architectural model with more layer and parameters in terms of runtime and accuracy. Next. Okay. The methodology, there is 3 steps in the methodology. There is data collection, data processing, and data analysis. In data collection, we obtain the data set from table set, namely resident pieces. This data set performed is 3,355 dB file divided to 2,684 file to training and 671 file for validation. And there is available in this dataset. Ground spot is 530. Next. Okay, let's move on to data processing. There is three more steps in data processing. There is pre-process, modeling, and writing. The pre-processing step is use data augmentation technique and layer normalization. The data augmentation technique is used to add more variety of data, and the layer normalization is used to distribute the data as well. In the modeling, we use CNN efficient B0 as the model. Model optimization is achieved through the pre-training and fine-tuning overall performance and efficiency. We choose the efficient B0 because this model has fewer parameters but good accuracy. The evaluation to evaluate the model's ability with new data, we use a cross-validation, that is couple cross-validation. And to see the result through multi-class classification, we use confusion metric. Next. Next slide. Okay, there is the data analysis. The data analysis is done by analyzing error through the pattern or unique characteristic that cause the error. We can see this analysis in the plot. That in confusion metric, and the second one is done to assess and understand the model's weakness and can provide insight how to improve it. This can see in the cross-validation process, that is the ability model to learn new data, and the analysis was carried out in its experiment and study. Next. The results and discussion. The classification was conducted through a series of experiments and evaluation the impact of various techniques applied to the test model in order to achieve optimization. This result, there is three experiments: pre-process experiment, learning rate experiment, and optimization experiment. In a pre-processing experiment, the model uses the item optimization function with learning rate 0.001. So scale experiment focus on assessing the impact of alternative optimization function in different learning rate configuration, and the device used is 64-bit Windows 11 laptop equipped with an Ryzen 5 CPU and 12 GB of RAM. Next. This is the first experiment, that is pre-process experiment. The pre-process experiment is, there is two, data augmentation and normalization layer. In the data augmentation plot, we can see that the plot is tells us that this model is overfit. We can see the validation and trend accuracy is very different. The validation accuracy is not increased but stagnant, but constant and fluctuative. In the second experiment, in the normalization layer, this problem is fixed with a normalization layer because the assumption of the first experiment is because the model is become too complex, because the data augmentation is generate the data and model is too heavy to feature learning the image, and the distribution of data is like we need normalization layer to distribute the data and simplify the feature learning. Next. That is the tabel that this experiment with promising result from this experiment. The next task focus on modeling. Experiment will explore the effect of optimization function and learning rate and parameter configuration. Next. The second experiment is model optimization using optimization function. We use three optimization function. There is SGB, RMS prop, and ADAM. As you can see, the RMS prop plot and the ADAM plot is similar, but the RMS prop is smoother than the ADAM. That is mean the ability of RMS prop to achieve the convergence is good than ADAM. But when we see the SGD, the plot is very different from this organization function. This because the SGD is have less ability to achieve the convergence. There is validation accuracy is higher than trend validation. This is because the ability of this model when generate new data is better than trend. When validation is better than trend. Next, this the table. As you can see, the RMS prop and ADAM have a similar result, but the RMS prop is higher result. Experiment was conducted to determine that the error rate for each iteration of the RMS prop optimization function. Next. The final experiment is learning rate experiment. There is three learning rate, 0.1, 0.01, and 0.001. The best result is conducted by 0.001 learning rate. As we can know that high learning rate is good for the time when computational process, but there is a weakness when there is fluctuative, and the low learning rate is good in the accuracy but very low. Then we need to find the correct learning rate that is not higher and not lowest. Next, there is the table. When higher learning rate equals accelerate model progress, the total running time in this training process is 3 hours and 14 minutes. Next, this is the result. In the evaluation, the model evaluation was executed using 5-fold cross validation with accuracy 74.14%. And this validation process is moving to 8 hours and 42 minutes. Next. The conclusion that following the series of experiment product, the most optimal result has been achieved through the preprocessing time.
We have to get QA question and answer. Thank you. Next presentation. Is there any question? Nice. Nice research, yeah. Usually, in the case if we get the overfitting, we can solve the problem using augmentation. But here, you do the augmentation data, but the model is still overfitting, right? And it is interesting that you can solve the problem by using non-layer normalization. What kind of augmentation data you use? And practically, what you do in the layer normalization?
Okay. Let me answer that. This model can this model is overfit when data augmentation because the dataset that we use is very large. There is 8 GB dataset, and the model is tiny fewer parameter assumption of us is the model is tiny and the dataset is very big and the data augmentation is cause the model is become more complex because this process is generate a new data that from the data. The process we do in data augmentation is flip, rotate, contrast, and then translation. In the normalization, we focusly distribute the data of the model for uh, the model the can do the computational process is more efficiently and simplify this process.
Thank you for the question. Okay, let's give applause to terima kasih. Okay, next presenter is Ibu Susana, Mr. Susana. Okay.
Okay, thank you. Hi, everyone. My name is Susana. Today, I will present my research and theme. The title of my research is Classification of Very High Resolution Remote Sensing Image from Object Using Deep Learning. Author for this of this paper is Susana, who is me, Miss Kastin Fatika, and Mr. Ahmad Saiku. The outline of this presentation is introduction. There's include the previous work, main contribution of this research, experiment validation about the dataset and experimental setup, and the experimental result. As an exploratory and observation technology, remote sensing has developed rapidly to produce a wealth of information that can be accessed easily. The information makes remote sensing imagery widely used in land use and land cover research. Accurate analysis and recognition of remote sensing images are essential for the sustainable use of land resource. Utilization of the increasing availability of remote sensing imagery includes land cover classification and scene classification. Land cover classification is vital in many applications, such as land resource management, urban planning, precision agriculture, and environmental protection. Despite advances in image processing, large area classification remains difficult for very high resolution satellite imagery. This is because very high resolution imagery exhibit binary details that pose challenge for accurate model prediction across heterogeneous landscape. In the classification process, many annotated datasets are used in the training process to produce an accurate model, and an efficient framework is needed to manage many pixels in the classification process. This is the previous work about remote sensing image classification. The first, Mr. Wang et al. In the paper on Computer Angle Science Journal in 2023 provide a parallel swim transformer network to mine feature context information for multi-scale semantic segmentation network for land cover classification. The second, Mr. Chen and The second, Mr. Chen, in their paper, provide a feature-wise transformation model to solve the cross-domain few-shot problem with limiting training samples. And the third, Mr. Huang, provide by converting the RGB color space into other color space, then use the image to train several CNN models. The problem of very high resolution remote sensing image classification and contribution. The first, the problem is large area classification remains difficult for very high resolution satellite imagery because it exhibits finer details that pose challenge for accurate model prediction across the heterogeneous landscape. The contribution of this paper is we propose modifying the convolutional layer in the CNN architecture to get a better accuracy. The second, we propose adding the dropout layer on certain block in the convolutional layers and another dropout layer in the hidden layer. This is the architectural workflow of MACNN. We use the CNN architecture to develop our proposed model that we call MACNN. MACNN use 9 convolutional layer for satellite image classification. We arrange the convolution layer starting with 224 filters of 3 by 3 size up to the 9 convolutional layer. The activation function in each convolutional layer is rectified linear unit activation function. The input image size is 56 by 56 pixels in 3 channels. There are 3 convolutional layers that have same number of filters, the 3rd convolutional layer, the 7th convolution layer, and the 7th convolution and the 9th convolutional layer. We apply layer dropout on certain blocks in the convolutional layer with a dropout value of 0.2 and another layer dropout in the hidden layer with a dropout value of 0.3. There is one hidden layer containing 448 neurons and using the rectified linear unit activation function, while the output layer is the softmax activation function with 15 neurons. This is the framework of the proposed method. The proposed framework for this study, satellite image classification model is using the publicly available GID dataset. Image preprocessing is performed on the input image, and then all images are randomly divided into training and testing dataset. The feature extraction process was performed on the training image before training in model building. In the training process, 100 epochs are used, and the label of the training dataset serves to measure the accuracy of the training model. After the model is successfully built, then proceed with the testing stage. At this stage, feature extraction is also performed on the input image from the testing dataset before it is classified. The built model is applied to the classification process to produce a prediction label. The classification result will be evaluated by comparing the predicted and actual labels. Then the data set of this research. We use a GID dataset, Kaufman image dataset. This is a large scale. This is a large scale land use and land cover classification dataset, which is consists of 2 types of dataset: large scale classification set and fine land cover classification set. In this result, we use a fine land cover classification set with RGB band, 30,000 image slice. There is 15 class, and each class have a 2,000 image slice. The image patch in the fine land cover classification set are divided based on the Pareto principle, which is used the ratio of 80 for training and validation, which is consists of 24,000 image and 20% for testing, and which consists of 6,000 image. This is some of the example of the image. The evaluation metric that we use on this research is precision, recall, F1 score, intersection over union, over accuracy, mean intersection over union, and mean pixel accuracy. This is the experimental result. It can be seen that from the 3 measurement metric used, the MACNN show better result than other method of the mean intersection over union and MPA metrics. MACNN improved 2.1% compared to parallel swing on the mean intersection over union value and improved 5.06% compared to parallel swing on the mean pixel accuracy value. This is the intersection over union comparison of each class in GID between MACNN and other methods. In comparing the IOU result in each class, it can be seen that MACNN improved in 8 classes compared to other methods. Although 7 classes have lower intersection over union value than other methods, the real class significantly increase intersection over union value. The conclusion of this research. First, in this research, we propose the classification approach based on the CNN model with architecture modification to the convolution and dropout layer and apply it to the GID dataset. This approach outperforms other method from the mean intersection over union value of 67.23% and the mean pixel accuracy value of 80.08%. It also exceeds 8 out of 15 classes compared to other methods based on the intersection over union value. Furthermore, this approach prevents overfitting in training and validation. That's all for me. Thank you.
I want to ask about the parameter in the training because you use a very high data set for 3,000 images. So I want to ask how many inputs and anything else to set the training parameters.
Can you? Okay, Ms. Susanna.
Yes. About the epoch of the that I use in this for train the model, I use 100 epoch to train this the model.
Other information I
I'm sorry.
Okay, you use 100 efforts. How many? How long that takes to train the model? And yes,
I'm sorry.
how long to train the test sample and the validation sample?
I use ICTS NVIDIA server, so about 2 hours to train the model.
Okay, thank you.
Okay.
Thank you.
Thank you, Susanna. Nice presentation.
Thank you.
Let's keep close to Now we move to the last presenter.
Excuse me, is my screen visible?
Yes. Are you and this guys end up commenting?
Yes, that's right. Mrs. Enda Purwanti is right now sick, so I'm one of the delegation for the presentation.
Are you the co-authors of the article?
Yes, I am Marcela Aurelia, the co-authors.
From Airlangga University, right?
Yes, through Airlangga University.
Okay. You have 15 minutes for presentation.
First of all, good afternoon, everyone. I am Marcela, and I am grateful to be part of the 14th International Conference on Information, Communication Technology, and System, or ICTS. And also, I am working under the guidance of Mrs. Enda Purwanti, and I wanted to express my gratitude for the opportunity to present our paper titled Anemia Detection using.
There is a blank windows in the screen. Could you just close the window?
Oh, I'm sorry. This okay?
Okay. Okay. Okay.
Okay, thank you. So I'm just gonna start. Anemia is a condition where the level of hemoglobin in the blood is below normal limits, which can cause disruption of the oxygen transport system. Based on the data from the World Health Organization, the number of anemia sufferers in 2016 was 39% women of reproductive age and 46% of pregnant women. Low hemoglobin levels in people with anemia can lead to more serious illness if not detected and treated as soon as possible. It could cause arrhythmias, disorders of the heart and kidneys, and can also affect hearing loss. The process of detecting and screening for anemia is carried out in two stages, non-invasive and invasive. The doctor performs a non-invasive examination in the form of checking the patient's medical history, symptoms experience, and physical examination, such as identification of pale color, several parts of the body, where the pale color indicates the presence of decreased hemoglobin levels in the blood, which can then be used to detect anemia at an early stage. Patients with more serious symptoms will be examined through invasive methods by taking blood samples, which tends to require a longer time to obtain the result and more expensive with a relatively low level of effectiveness in handling large numbers of cases. In addition, this invasive examination process is one of the factors causing people to be reluctant to do anemia tests because they are afraid to the blood sampling process. In the study, it was found that the pale color of the conjunctiva of the eye has the greatest influence of the anemia profile, which is equal to 9.43% when compared to other body parts. In the study, the sensitivity and specificity values for pale body color in the process of diagnosing anemia were 94.02% and 93.71% respectively, so that it can be said that the conjunctiva of the eye is the best object that can be used for diagnosing anemia. In Tamir study, anemia was detected using red and green spectrum components from anterior conjunctiva images, and the result of the test was 78.9% of accuracy. In the Melrose research, anemia was classified using several methods and obtained the best accuracy 76% using the k-nearest neighbors classification algorithm. Based on the previous study, research on the classification of anemia still relies on traditional machine learning algorithms, and deep learning is a machine learning algorithm that is reliable in feature learning and automatic pattern classification, and one of the algorithm in deep learning is convolutional neural network, or CNN. And this study aims to classify palpebral conjunctiva images for anemia identification using the CNN method with three architecture, namely AlexNet, ResNet 50, and MobileNet v2. The data is downloaded from the IEEE data port. Each folder contains 3 images, including eye images, palpebral conjunctiva images, and fornical conjunctiva images, and is equipped with a file with extension XLS, which contains information about hemoglobin concentration, age, and sex. The research method, including literature study, data collecting, data labeling, pre-processing, which contains of cropping, augmentation, and resizing, and then final data where the data split into 3, 70% for training, 20% for validation, and 10% for testing. Then classification, which in this research will use tree architecture, and lastly, the analysis. CNN is a deep learning algorithm that utilizes the concept of convolutional in its feature extraction process automatically and the classification process at the final stage. CNS has an architecture that consists of several layers, including the convolutional layer, pooling layer, activation function, and fully connected layer. AlexNet has 8 layers consisting of 5 convolutional layers and 3 fully connected layers. Then the ResNet 50 has 50 layers consisting of 48 convolutional layers, 2 pooling layers. This architecture is made in several blocks and uses the concept of skip connection to the vanishing gradient problem found in the previous architecture. MobileNet v2 has 53 layers with 17 bottleneck residual blocks, an input layer, and 1 fully connected layer. Each bottleneck residual block consists of 3 more layers in it, namely 1 convolution layer with ReLU6, 1 device convolution layer, and 1 convolution layer with an activation function. And here's the result of the pre-processing, the cropping, then the augmentation that applies several operations, including horizontal flip, vertical flip, and random brightness contrast, and resizing. And here's the result of the model performance. The first one is AlexNet with a total of 10 iterations. And based on the graph, it can be seen that the training accuracy results are quite good because of the accuracy value increases with the increase in iteration, which means that the AlexNet model learns features better for each iteration. Furthermore, the value of training loss decreases with an increase in the number of iteration. And this shows that the AlexNet model training data gives a smaller prediction error as the number of iteration increases. However, there are a quite huge fluctuation of the validation accuracy and loss, which means that the AlexNet model was unable to validate the palpebral conjunctiva image data, so it could not be classified properly, which caused prediction errors by the AlexNet model. Then the second architecture is ResNet 50, which trained for 10 iterations, and the results obtained are shown in the following graph. Based on the graph, the value of training accuracy tends to always increase in proportion to the increase in iterations. So this value indicates that the ResNet 50 model can learn features and classify palpebral conjunctiva images well. However, the value of validation accuracy tends to fluctuate a little in certain iterations, even though the value of the decrease is not significant on the performance of this model. And the model has successfully reached almost 98% of accuracy. Plus, the following graph is the result of training and validation for MobileNet v2 architecture. Although there are unstable values during the validation process of some of the iteration, but overall, the accuracy and loss in this model is good, and also the accuracy successfully reached 97%. After analyzing the 3 different approaches for the classification of the anemia through palpebral conjunctiva images, it can be concluded that the ResNet 50 model has the best performance, which the accuracy reaches 97.94% with the loss value of 0.0631. And the second best is the MobileNet V2 with the accuracy 97.19% with the loss of 0.0647. And the last is AlexNet with the accuracy 89.93% and the loss is 0.2701. The performance of FastNet 50 can be considered a strong approach because of the existence of a skip connection on the residual block in the ResNet 50 architecture is able to overcome the problem of errors during training and validation due to underfitting. And here are some of the references we use in the study. And that's all for the presentation. I apologize for any shortcoming in this presentation. Thank you and good afternoon.
Any question from audience? Could you explain the technique you use for pre-processing so that from the image you can get the part of what is called the quantitative area of image.
Okay, the conjunctiva palpebral. Let me share my screen again. So firstly, we got this data, the eye with the conjunctiva, and then we crop this conjunctiva. So what will be classified is the conjunctiva.
I mean, how do you crop? Because I think the technique is just not cropping using a rectangular area because the part you want to classify using CNN. It's not rectangular, right? There is a rectangular. So how do you get this part of image from the eye image? Because if you use just crop, then I think you can get maybe also at the area, just slice like this. Maybe just using a specific tools, maybe.
Okay, thank you for the question. For the conjunctiva, for the crop conjunctiva is also provided in the data sets. So we also use that.
Okay, thank you.
Okay, thank you for the questions.
Okay, thank you, Mr. Marcella. Let's give applause to Mr. Marcella. And this is the end of the session in this room. So, certificate will be sent by the ICTS committee by email. Yeah. To be announced later. And maybe we will take a pause. No? Okay, then thank you very much for your attention.